Good day, lecturer. My name is Sanjay Paniswaran. My metric number is 10 DKM 19F1046. Today, me and my group mate will be presenting for Engineering Society, and the topic is sustainability and green engineering. Firstly, I'll start with determining sustainability and green engineering. What is sustainability? Method of harvesting or using a resource to make sure it is not damaged and fulfill the needs to the present without compromising the ability of future generations to meet their own needs. In addition to natural resources, we also need a social and economic resource. Sustainability is not just environmental. Embedded in one definition of sustainability, we also find concern for social equities and economic development. Following by what is green engineering? It is design, commercialization, and use of process and product that are feasible and economical. Green tech refers to a type of technology that is considered environmental friendly based on its production process or its supply chain. Green tech, an abbreviation of green technology, can also refer to clean energy production, to use of alternative fuel and technologies that are less harmful to the environment than fossil fuel. Did you know adopting sustainability practice, whether large or small, can have significant impact in the long run? In every office worker in the United Kingdom, use one less stapler a day by using a reusable paper clip, 120 tons of steel will be saved in 1 year. Following by sustainability. What is sustainability and what it contains? Resources, production, and lifestyle. Resources mean what we have, production means what we make, and lifestyle means how we use it, the application we are using in the sustainability. And sustainability development. Socialized progress characterized by the fulfillment of human needs while maintaining the equality of the nature environment identificationally. Sustainability development is an organization principle for meeting human development goals while simultaneously sustaining the ability of natural system to provide the natural resources and ecosystem service on which the ecosystem and society depends. The desired result is a state of society where living conditions and resources are used to continue to meet humans' needs without undermining the integrity or sustainability of the natural system. Sustainability can be defined as development that meets the needs of the present without compromising the ability of future generations to meet their own needs.
Okay, good day, sir. My name is Kesivara Chandran. My metric card number is 10 DKM 19F1027. I am from DKM 5B. Now, I would like to explain more about green technology, the principles of green technology. Engineer processes and products holistically uses system analysis and integrate environment impact assessment tools. Conserve and improve natural ecosystem while protecting human health and well-being. Use life cycle thinking in all engineering activities. Ensure that all materials and energy inputs and outputs are as inherently safe and begin as possible. Minimize depletion of natural resources. Strive to prevent waste. Develop and apply engineering solutions while being cognizant of local geography, aspirations, and cultures. Create engineering solutions beyond current or dominant technologies. Improve, innovate, and invent technologies to achieve sustainability. Actively engage communities and stakeholders in development of engineering solutions. Hence, we see about present engineering problems. We have four engineering problems, which are wireless radiation, hazardous air pollution, heat radiation from electronic devices, industrial solid waste. Firstly, we see about wireless radiation. The antennas contained in mobile phones, including smartphones, emit radio frequency radiation. The part of the head or body nearest to the antenna can absorb this energy and convert it to heat. Secondly, hazardous air pollution. Hazardous air pollutants, also known as toxic air pollutants or air toxics, are those pollutants that are known or suspected to cause cancer or other serious health effects, such as reproductive effects or birth defects, or adverse environmental effects. Thirdly, heat radiation from electronic device. Heat radiation from electronic device is electromagnetic radiation generated by the thermal motion of particles in matter. Thermal radiation is generated when heat from the movement of charges in a material, electronics and electrons and protons in common forms of matter is converted to electromagnetic radiation. All matter with a temperature greater than absolute zero emits thermal radiation. Particle motion results in charge acceleration or dipole oscillation which produces electromagnetic radiation. Fourthly, industrial solid waste. Industrial waste is the waste product produced by industrial activity which includes any material that is rendered useless during a manufacturing process such as that of factories, mills and mining operations. Thank you, that's all from me. Now my friend will explain about the other slide.
Hello sir, my name is Arvind Kansami. My matric card number is 10DKM19F1103. Today I would like to explain about how green technology could be achieved. The first is using eco-friendly green technology. The example of eco-friendly green technology is grey water recycling. These technologies, which are the best set up together with a rainwater harvesting system, allow one to reuse water that was just used for another job. The water that can be reused by this type of system can be rainwater or main waters. The next is about solar and wind hybridizing technologies. The fact that Earth Hour participants are required to switch off all their home appliance and light for 1 hour is proof that the electric power you will use comes from less than ideal sources harmful to the environment. Good thing a number of multinational companies these days have made or are the transitioning to solar and wind advertising tech. After all, solar power and wind are renewable clean sources of energy. The next is about reduce, recycle and reuse. These three are equals to words are the important part of sustainable living as they help to cut down the amount of waste we have to throw away. It's really simple. Reduce the amount of waste your product, reuse item as you can before replacing them, recycle item wherever possible. Using 3Rs also help to minimize the amount of space needed for landfill sites where waste materials are disposed of. The first R equals to how can I reduce the amount of water I produce. The first R is about creating less waste. Here are some of the ways you can do this. Only buy whatever you need. Choose product with less packaging. Buy in bulk. Look for items that you can reuse. Reducing the amount of waste we all generate is a great way to benefit the environment. The second R is equals to how can I reuse what I have. The second R looks to how you can reuse created item again identically multiple times before replacing them. Here are some ideas. Refill a bottle with a water from home instead of buying a new update of computer rather than throwing it out, getting a replacement, ditch plastic bags and choose reusable, environmentally friendly bags instead. The third R is how can I recycle the product I use? The third R is about making sure you separate items that can be recycled, meaning they can be used for a new purpose. The materials that can be recycled include glass, cardboard, aluminum, and lead batteries. The next slide is about classify sustainable and green technology. A model based on three moral imperatives, which is satisfying human needs, ensuring social equality, and respective environment limits. The next is refers to four distinct areas: human, social, economic, and environmental. Defined as developing or growing by using recycled materials or renewable resources while building. Sustainable is large about people, their well-being, equality in their relationship with each other. The next is correlate the role of engineering towards sustainability and green engineering. Green engineering will design transport systems that will be more effectively, create few advertised environmental impact, create long life facilities that can be maintained at lower cost. The next is engineers will develop resources including plain water cleaner, effective mining and petroleum operation. The next is water resources planning of all kinds. The lastly, improvement and land planning to protect valuable agriculture, land and natural resources impact for urban sprawl. That's all from me, sir. Thank you. The next slide will be continued from my friends.
Good day, sir. My name is Nageshwaran. My medical number is 10KM19F1015. I would like to continue with the correlate of the role of engineer towards sustainability and green engineering. Engineers will develop resources in a sustainable way, developing instrumentation to measure and monitor pollution, changing industrial processes to reduce energy use and eliminate the waste, and collaborating with other industries by creating eco-parks. Processing and modifying resources in the past, many industries generated waste products that were toxic and not easily degraded under natural conditions. And the work of engineers underpins industry's capacity to make major changes in the ways they use raw material to produce products. By reducing their waste to minimum, many industries are finding that improved processing leads to increased profits. In an eco-park, several industries would work together so that each industry waste products will be used as a raw material for others. This also makes possible more efficient use of waste heating, cooling water and using combined waste treatment facilities. Next point would be engineers will recover and reuse previous resources. Improved ways to recycle and reuse domestic waste. Designing better solid waste collection and storage facilities. Lastly, improving treatment facilities for urban waste to be used safely for agriculture. In worldwide, 80% of all the product waste are thrown away after one use. The figure would not be substantially different in other developed nations or countries. For sustainable development to be possible, our human activities will have to be redesigned to reuse our raw material and consumer products many times over. The screen lists just some of the way engineers can assist in better resources recovery and reuse way. Next point is engineers will conserve and reduce the use of energy. Engineers could design the energy efficient buildings and engineers could design using low energy lighting systems. And engineers could make increasing the use of underground constructions. Energy production and use. Humans consume more fossil fuels per year than natural produces in a million years. Emissions of carbon, sulfur, nitrogen, and other products could create unacceptable level of pollution and threats to the Earth's climate. One of the greatest engineering challenges for the future would be to develop environmentally damaging sources of less environmentally damaging sources of energy while simultaneously reducing total energy consumption. So in the future, the roles of engineers in the energy production may include those things listed above. Next point would be engineers will use IT, which is information technology, to contribute to and enable sustainable development by maximizing the efficiency, creating tools for sustainability, and finally networking with nature and redesigning the products into services. Now, I would like to explain on our case study which we choose aquaponic system. So what is aquaponic system? Aquaponic is a food production system that couples aquaculture with hydroponics, whereby the nutrition-rich agriculture water is fed to the hydroponically grown plants when nitrifying bacteria conversion ammonia into nitrates. Aquaponic is a cooperation between plants and fish, and the term originates from the two words aquaculture. Aquaculture, the growing of fish in a closed environment, and hydroponics, which is the growing of plants usually in a soil-less environment. This is the green technology application that we choose for our case study. And that's all from us, sir, and thank you.